Hello and welcome to our video on circle theorems. Today we're going to be looking at cyclic quadrilaterals. So before we begin, we need to understand what the word cyclic means. So we need a definition for the word cyclic. So here is your definition for the word cyclic. Cyclic means a shape where all the vertices are on the circumference of a circle. So if I started at a vertex, I could travel along each edge and reach the vertex I started at. So for example, here is an example of a cyclic triangle. So if I travel along this vertex here, so this vertex, this corner is on the circumference of the circle in green, and if I travel along, I can see that I would go to the next corner, which is also on the circumference, and the last corner, which is on the circumference, and back to where I started. So this is a cyclic triangle. Similarly, this is a cyclic pentagon. So we need to know what the word cyclic means. It's a shape within a circle where all of the corners, vertices are on the circumference of the circle, and we can travel along the edges and get back to where we started. So the one we're going to be looking at specifically is cyclic quadrilaterals. Now the circle theorem for cyclic quadrilaterals is that diagonally opposite angles in a cyclic quadrilateral sum to 180. Now we need to understand what makes it cyclic again. So pause the video. What makes this shape cyclic? What makes this quadrilateral cyclic? Pause the video. Have a think. Okay, so what makes a shape cyclic? Well, we said a shape is cyclic if the vertices, the corners of the shape, is on the circumference of the circle. The vertices, the corners of the shapes, are on the circumference of a circle. And we can see here that we do have that in this quadrilateral. The corners of this quadrilateral, the vertices of this quadrilateral, is on the circumference of the circle. Now, what do we need to happen for this circle theorem to be true? Well, first of all, the shape must be inside the circle. If it's outside the circle, it would be impossible for the vertices to be on the circumference of the circle. The second thing we need to also remember is that the quadrilateral must be created by four chords. If these two constraints are met, then it will be part of this circle theorem. It will be a cyclic quadrilateral, and the diagonally opposite angles will be equal. So if you have a look, the two darker grey angles are equal and the two light grey angles are equal. If you wanted to do that in terms of algebra, because it's really important that we can generalize these things, we look at the second diagram. We have A and B, which are diagonally opposite, and C and D, which are diagonally opposite. And because of our circle theorem, we know that A and B must sum to 180. And of course, C and D must also sum to 180 because they are diagonally opposite angles in a cyclic quadrilateral. So here's what we're going to do for the rest of this lesson. We're going to try and ensure that we can spot cyclic quadrilaterals, because if you can spot cyclic quadrilaterals, we can then spot diagonally opposite angles. So here's what we're going to do. Here's going to be your task. You're going to be given a shape. I'm going to ask you to pause the video and then think, is this shape a cyclic quadrilateral? Is this quadrilateral cyclic? Pause the video, have a think. Okay, so we need to remember the two constraints we need to have for this circle theorem to work. The first one is it needs to be on the circumference of a circle. So there it is. There's the circumference of my circle. I can see that all 4 points are on the circumference of the circle, and then I can also see that the quadrilateral is made up by chords. The quadrilateral is made up by chords, so therefore this quadrilateral is indeed cyclic. Here's your next one. Pause the video. What do you think? Okay, for this one, we can see that we have a circle. There it is. There's the circumference of the circle. Unfortunately, none of these lines that create this rectangle for us are actually chords. None of them are chords. So this shape is not cyclic because none of the points are on the circumference of the circle. None of these lines are chords. Okay, what about this one? Pause the video. What do we think? Okay, so this one, there it is. There's our circumference of our circle. But what's the problem? Why is this shape not cyclic? Well, we can have a look and we can see that we only have two chords that make it up. Only 3 of the vertices are on the circumference of the circle. The 4th one is not. So this shape is not cyclic. What about this one? What do you think? Pause the video. Okay, so let's have a look at this one. It is within a circle, so there's the circumference of our circle. However, this shape is not a quadrilateral. We have not joined up the shape. We have 4 chords, but the chords aren't connected. The chords must be connected because we do not have a quadrilateral here. This is an open shape. It's not a quadrilateral. It's just a collection of chords. What about this one? Is this a cyclic quadrilateral? Pause the video. What do we think? Okay, so for this one, once again, we're going to need to think, where's the circumference of our circle? There it is in green. We have 2 chords. Now, the other 2 lines, although they look like chords, they aren't because they go outside of the circle. Remember, chords are within the circle. Chords are within the circle. Okay, so this shape is not a cyclic quadrilateral. What about this one? Is this a cyclic quadrilateral? Pause the video. What do we think? Okay, so this one, here is our circumference. So there's the circumference in green. So we have 2 chords here instead of 4. Remember, we need 4 chords. So although this is a quadrilateral, because we only have 2 chords, this is not a cyclic quadrilateral. Remember, we need 4 chords and all of the vertices must be on the circumference for it to be cyclic. What about this one? Is this a cyclic quadrilateral? Pause the video. What do you think? Okay, so here is our circumference for this shape. Here's our circumference, and we can see that the quadrilateral is outside of the circle. So these lines that create this quadrilateral are not chords, they're tangents because they're outside of the circle and they touch the circle at one point. So this is not a cyclic quadrilateral. What about this one? Pause the video. Is this one a cyclic quadrilateral? Okay, so let's have a look. Do we have a circumference of a circle? There's our circle, right? Do we have 4 chords? Yes, we do. But because all 4 vertices of this quadrilateral are not on the circumference, so although we have 4 chords, but the vertices are not on the circumference, this is not a cyclic quadrilateral. So before we finish, let's just summarize what you should have taken away from this video. The summary of this video is as follows. Diagonally opposite angles in a cyclic quadrilateral sum to 180. That is the circle theorem that you need to know and understand. And the last one is what makes this circle theorem happen is the vertices must be on the circumference of the circle and the quadrilateral must be made of 4 chords. As long as it fulfills these 2 criteria, the quadrilateral is cyclic and therefore the diagonally opposite angles will sum to 180. Now what I suggest you do is if you're feeling happy and you're confident with this video, you go and watch Mr. Amoson's video and do some practice questions there. If you're feeling super confident, you go on Dr. Frost and Corbett Maths and practice some questions on your own. Go off, be productive, and I'll see you in the next video.